Today we're going over chapter 24, Comparing Two Means. The flight distance in inches of two different models of paper airplanes is listed below. Create a confidence interval for the true mean difference of the flight distances for the two planes. So I have plane A and plane B, and it's listed there. We're going to have to name the confidence interval. So make sure you name the confidence interval with a two sample t interval for the difference in means. Step one is identify the parameters. So once you name the interval, you need to identify the parameters. The mean distance for plane A would be mu A, and the mean flight distance for plane B would be mu B. Step two is we need to check the assumptions. Make a picture for each set of data. I decided to use a histogram, but you can also use a normal probability plot for these data. Talk about the pictures. Both histograms look roughly unimodal and symmetric, so it is reasonable to believe that the flight distances of each could be described by normal models. These are not random samples, but they are hopefully results of a controlled experiment. Flight distances for each plane should be independent if the planes were not damaged in previous flights or a new plane was used for each trial. 10 is less than 10% of all possible flights for each plane. And the results of the two groups can be assumed to be independent if the experiment was properly controlled. So you do need to talk about that if it doesn't say anything about it. So the use of a two sample t interval is justified. So now, like I said, you need to name the interval. So it's a two sample t interval for the difference in means. And we need to also write the formula for that down and then plug all the information in we get from our calculator, and I'll talk about that in a minute. So let's go ahead and write our formula down. So it's going to be x bar A, meaning the mean flight distance for plane A, minus x bar B, the mean flight distance for plane B, plus or minus t star, the square root of our standard deviation of A squared all over the number of trials for plane A, plus the standard deviation of B squared all over the number of trials for plane B. Okay, so what we can do is we can get our interval, and all the information will be given to us when we get our interval. So if you go to stat and go to tests and choose 0 2 sample t interval, we're going to use the data we plugged into list 1 and list 2. So plug in plane A into list 1, plane B into list 2. That's what list 1 and list 2 is. Frequency is 1 for both of those. For this, we're going to do a 95% confidence interval. It wasn't stated in the problem, but it usually is. And it's never pooled. So you always have no for pooled. And then you choose calculate. It's going to give you your confidence interval. Then it's going to give you all the numbers you need to fill in this information here. So you do want to plug it into the formula before you write down your confidence interval. And I'll talk about T star in a minute. So it gives you X bar 1, X bar 2, so that's plane A, plane B, standard deviation 1, standard deviation 2, plane A, plane B, and it's 10 for each of the number of trials. Now, we also need to be able to find T star. To find T star, you need the degrees of freedom. They give you the degrees of freedom right here. Okay, so to find T star, you would go to distribution, which is the second in bars key, and choose number 4, inverse T. Our area is measured from the left, so it's 0.975 because you have that 0.025 on either side of the curve. We go ahead and we plug our degrees of freedom in, you choose paste, and it gives you your T star of 2.101 about is what we're going to use. So we need to go ahead and plug all of this in. So we would have our mean would be 148 minus 128.6 plus or minus T star was 2.101 times the square root of our standard deviation is 20.99 squared all over 10 plus our standard deviation for plane B is 19.81 all over 10. And this gives me the interval of 0.22126 to 38.579. So you have your confidence interval. So now what you need to do is you need to interpret this confidence interval. So you would say something like, I am 95% confident that the true mean difference in flight distances between the two planes is 0.22 inches and 38.6 inches, where plane A's flights are longer. So now we're going to do a two-sample t-test for the difference in means. So again, we need to identify the parameters. So mu A would be the mean flight distance for plane A, and mu B would be the mean flight distance for plane B. We need to write our hypothesis. You can do one or the other. You don't need to do both. So the flight distances equal each other, or they don't equal each other, or the difference equals 0 or doesn't equal 0. You need to check assumptions and conditions. If this hasn't been done in a confidence interval, you need to go through and do them. Since these were checked when we constructed the confidence interval, we wouldn't need to check them again. So now we're going to go through and you need to name the test. The test is a two-sample t-test for the difference in means. And now we need to find the test statistic and the p-value. So the test statistic is t equals x bar A minus x bar B minus 0, because that's usually your null hypothesis, mu A minus mu B, which is 0, all over the square root of our standard deviation of A squared divided by the number in sample A plus our standard deviation of plane B squared divided by our number in sample B. So again, you can go through and put this in your calculator and then plug it into your formula. You need to plug it into your formula. So if you go to stat and over to test, it would be number 4, a two-sample t-test. We're going to use our data that's in list 1 and list 2. We're doing a hypothesis test that is not equal to. Pooled is always no. Then you choose calculate. When you choose calculate, it gives you your t-value, which is this right here. It gives us our p-value. We'll talk about that in a minute. Degrees of freedom again. X bar 1, X bar 2, standard deviation of the first sample, standard deviation of the second sample. And then if you scroll down, it would give you the number in the first sample and the number in the second sample. So we're going to go ahead and plug this information in. So we would have 148 minus 20.99 minus 0 all over the square root of 20.99. Oh, I made a mistake. I looked at the wrong value here. So let's fix that. So it would be 148 minus 128.6 minus 0 all over 20.99 divided by 10, and that 20.99 is squared, plus 19.81 squared, all divided by 10. And this gives us a t-value of 2.126. And I want you to write down your p-value, and that equals 0.048. And when they don't give you a significance level in the problem, we're going to use a significance level of alpha equals 0.05. That's a typical one that you use to come up whether or not we reject or fail to reject the null hypothesis. Now, you want to compare your p-value. Our p-value compared to our alpha level would be less than, because our p-value is 0.048, which is less than 0.05. So because of that, you would reject the null hypothesis. So we're going to reject the null hypothesis because our p-value is less than our alpha level. So make a decision and state the conclusion. Reject the null hypothesis because the p-value is less than alpha. 0.047 is less than 0.05. There is significant evidence that there is a difference in the average flight distances between the two planes.